All right, I'm going to be posting this video. I'm going to finish up the rest of number one. We've already done the axis of symmetry and we've already done the vertex. I'm going to find the rest of them for you. I'm choosing number one because it's one of the more difficult ones to work with. But you're going to see how much easier the rest of these problems are once we get going with it. Okay, number one. Here's number one. Y is equal to ax squared plus bx plus c. Okay, remember that. Y is equal to ax squared plus bx plus c. Oops, sorry, that shouldn't be there. Okay, plus c. That little formula right there is just the formula of the quadratics. A and b are the coefficients for the x squared and the x. C is the constant. So in this case, the a is here. It's nothing there, so it's a 1. You can put it in if you want, if it helps you. The b is 3. The c is negative 10. We've already found out that the axis of symmetry, x is equal to negative 3 over 2. We already knew that. X is equal to negative 3 over 2. If you wanted to, you could come over to your graph and make your dotted axis of symmetry at negative 3 over 2, which is negative 1.5, okay, on your axis. And then we found out that the vertex, by substituting the negative 3 over 2 in for the x's and working this pretty ugly problem out, it came out to be a negative 12 1/4 or a negative 49 over 4. Oops, not a 1. 49 over 4, okay? Negative 49 over 4 is not easy to graph. Negative 12 1/4 isn't much better, but it's way down here, okay? We know that the vertex is on your axis of symmetry, and your graph, I can tell you right now it's going to open up. How do I know it without having doing any work in this problem? How do I know that? Because look at the value of a in your problem. Is it a positive answer or is it a negative answer? It's positive a. So if it's a positive a, that means your graph is going to open upwards. Open upwards. I just did that with my hands, and I don't know why. I'm on video. Okay? It means your graph is going to open upwards. Your parabolic curve, your parabola, will open upwards. So that means your vertex, which we've already found, our vertex in this case, because our a value is positive, that means our vertex will be the minimum of our graph, because that's what max or min is asking you. Is your vertex the maximum point in your graph, or is it the minimum point? Is it the top highest point it's going to be? I'm raising my hand. The top highest point, or is it the bottom lowest point? Well, not looking at the graph. The graph doesn't help you because you never know. Look at the value of a. It's positive. So if it's positive, that means it's going to open upwards and keep going. It's going to open up and keep going, and that means your vertex is the minimum value of your graph. It's the bottom. Easy one to do. If it's a negative, that means it's going to open downwards. That means your vertex is the maximum point in your graph. If it's positive, it opens upwards. It's a negative value. Makes sense? Makes sense? Good. We already know the axis of symmetry. I'll come back to the x and the y-intercepts. They're the last ones I usually do because all of the rest of the stuff will be helpful. The domain and the range, you've got to be careful. The domain and range, you've got to understand. Way back in the day, the domain and the range are just a different term for the x and the y values in your graph. So I'll start with the domains. In your graph, the domains are the x-axis, the x-axis. What points could you choose for the x values? Anything positive, anything negative. So your range is anything negative, infinity, and anything positive, infinity. That's your range of your answers for this problem. Negative infinity and positive, wow, that's just ugly. Negative infinity to positive infinity. Your x values could be anything on this graph because you can plug anything you want in for the x. Now your y values are dependent upon what you put in for x. Okay, they don't have an unlimited amount. On the y-axis, you only go down this far, down to negative 49 over 4. Okay, that's the lowest. Because remember we found it's a minimum, so that creates your range of y values. The lowest you can go is to a negative 12 1/4. Now, how high can you go on your graph on the y-axis? That is unlimited, okay? So your range is from a negative 12, because that's the lowest point that you're ever going to get. You can't go any lower because that's your minimum value of your graph. It opens upwards Dang it, I keep on moving both my hands. It opens upwards from that point. It doesn't go any lower. So your range only goes to negative 12 and 1/4, but it can go up on the y-axis unlimited, infinitely. Okay? Do we understand that? The domain is pretty much always going to be a negative and a positive infinity. Positive, negative, infinity. You may even see it written like this, plus or minus infinity. Because that's okay. Plus or minus infinity is a different way of writing the range of this problem, okay? Or the domain of this problem, I'm sorry. The range is, it goes from whatever, if it's your lowest point and higher, it goes from that point infinitely. If it was way up here, your vertex, it would be your highest point and lower, negative, okay? Infinitely negative. So those are done. Now for your x and y intercepts. Let's do the y-intercept because that's the easiest. What do you know about a y-intercept? Well, I know that the y-intercept has to have an x value of an ordered pair of 0. Okay, my y-intercept has to have a 0 value for x. So if I substitute a 0 in for the x here, that wipes out, and a 0 in for the x here, let me do that again. A 0 in for the x here, that wipes out, and a 0 in for the x here, 3 times 0 is 0. So 0 squared is 0, 3 times 0 is 0. 0 plus 0 minus 10. What is my ordered pair for the y-intercept? 0, negative 10. All righty, 0, negative 10. So I go to this and down to negative 10. That's my y-intercept. All righty, makes sense? That's my y-intercept for this graph. So I know right now my parabolic curve does this. Curves up to there. All right, now how do I find out my x-intercepts? This is where you've got to use a little bit of your prior knowledge of quadratic equations. You've got to set, what do we know about x-intercepts? We know that y is 0. So my ordered pair is y is 0. Now, there's going to be 2 of them. Here's a little bit of a trick here. I'll come back to this. Let's find your 2 x-intercepts. This one I know is going to have 2 of them because my graph opens upwards and it's going to cross the x-axis 2 times because it's got to. I mean, it's infinitely growing that way. So I'm going to put a 0 in for, oh, I can't right now. Let's go to my graph or my problem. Whoop, let me flip this over. In this equation, I've got to set the y equal to 0. 0 is equal to x squared plus 3x minus 10. I can't just solve this one the way it's written. This is one of those, the squares that we've got to factor the trinomial. I've got to turn this into and set it equal to 0. Remember when we did this? It was on like worksheets where you had to factor a trinomial. Then on the bottom of it, it said set it equal to 0 and solve for it. What are the x values? That's what this ties into. We're finding out our x values, where we cross the x-intercept. So when we're doing this and we factor this out, we've got 2 points. Watch this. I know because it goes plus minus, it's going to be x plus, x minus. I know that from my rules that I taught you before on factoring trinomials. Now you have to think about the factors of the number 10. You've got 1 and 10, 2 and 5. I don't have to go any further. I know that 1 and 10 aren't going to make 3. I know that 2 and 5 do. And it's a positive 3 in the middle. That means the bigger number is positive. 2 goes there. Not done yet. Now I've got to take each one of these, x plus 5, and set it equal to 0, and x minus 2, and set it equal to 0. I've got to find out both values of x that I can have for my intercept. Okay? Simple. This one is x equals negative 5, and this one, x equals 2. Okay? Those are your x-intercepts, negative 5 and 2. Okay? Negative 5 and 2. So let me go back. You could write them as ordered pairs. It doesn't bother me. It doesn't matter to the teachers. Or you could just write negative 5 and 2 for your x-intercepts. Watch carefully. Negative 5 is one of my x-intercepts, and 2 is my other. There's my parabolic curve. I've got my two x-intercepts. I've got my vertex. I found my y-intercept right there. All of those things help me plot the points. Now, something else you probably will notice is my vertex matches up pretty much over here, the same distance. 1.5, 1.5 over, and it should open up the exact same way. My drawing's a little cruddy, but it looks like that. That's how you graph a parabolic curve from the quadratics. All of these things we've just found. The axis of symmetry is first, the vertex is second. Axis of symmetry and vertex, those are the first things you find. Done. Then everything else is just plot it in and work it out. The range of the domain, simple. Minimum, maximum, simple. Now this one right here, the x-intercept, you have three different answers that you can get for that. For your x-intercept, let's quick look at this. You can have a graph, here's your x-axis. You can have a graph that opens like this one and has 2 points on the x-axis where it crosses the x-intercept, okay? So you can have 2 x-intercepts like this, or what if it is on the x-axis? Look at that. How many intercepts does this have? Or just one. But what if it has a vertex above the x-axis and opens upwards? Doesn't even intersect the x-axis. Not at all. Or none, or zero. Okay? So you will have all three of these, and you're going to see with the other ones that you've got a graph how they open, what they do. So you have 2 x-intercepts, 1 x-intercept, no x-intercepts. For a problem like this, it depends on where your vertex is and how your graph opens. When you find your vertex and you see your a value, let's say this one would have been a negative a value up here, and it would have opened downwards, I would have 0 x-intercepts. 0 x-intercepts, because if it opened downwards, it's not going to cross the x-axis. Okay? Is this making sense? So you will have one of 3 choices. So if you have any questions, try the rest of these, see how you do with them. I'm going to post the vertex and the axis of symmetry for numbers, 4, 5, and 6, I think it is. I'll post those in about 2 minutes, but I needed you to know this. Get to work on the rest of these and start working on them and finding the rest of the answers. Shouldn't be too bad. The toughest part is finding the axis of symmetry and the vertex. So good luck.